on page 6, we're going to start talking about something called a unit vector. A unit vector u for which the magnitude of u is equal to 1 is called a unit vector. In other words, a unit vector is a vector that has magnitude 1. Okay, that's all a unit vector is. Okay, it's a vector that has magnitude 1. There are two very important unit vectors that you need to know. They are defined as follows. The unit vector I is defined as 1, 0. Those are its components. And then the vector j is defined as the vector 0, 1. Okay, so let's go ahead and just graph these guys out. They're very tiny vectors. So what I'm going to do here is I'm going to make my scale very large. So let's see, on both of my axes, x and y, I am going to go by 0.25. So this will be 0.25, 0.5, and then 0.75 and 1. Okay, so I'm going to do this to both of the axes. So for this first vector, okay, this is going to be an illustration of the vector I, okay, which has components 1, 0. Okay, so remember this is a position vector, so its initial point will be at the origin, okay, and then its terminal point will be at the point 1, 0. Okay, so I'll go ahead and write this out. The initial point here is at the origin. The terminal point is at 1, 0. Okay, so right here, okay, and we draw our arrow from the initial point to the terminal point. Okay, so this unit vector parallels the positive x-axis here. Okay, all right, so now on the other grid, I will graph out the vector j, which has components 0, 1. Okay, first thing I'm going to do here is put the scale on the grid here. So let's see, this is going to be 0.5, and this is going to be 1, and then this is going to be 0.5 right here, because I'm still going by, every tick mark is going to be 0.25 units. Okay, this will be 1. So for this particular guy, it's also a position vector, so its initial point will be at the origin, but its terminal point will be at 0, 1. Okay, so it's going to start here at the origin. It's going to go up to the point 0, 1. Okay, connect the dots. Okay, so this vector is going to look like this. This is what the vector j looks like. Okay, it is lying along the positive y-axis. Okay, all right, so those are two important unit vectors you need to know. Okay, the reason being is, like, much of the time vectors are written in what's called IJ form. So in the box, let's talk about this IJ form for vectors. Okay, so here we go. It says if A and B are scalars and you have a vector V with a horizontal component of A and a vertical component of B, then we can write the vector V in this IJ form like this. Okay, in addition to being able to write it in component form with the brackets that look like angles, AB, you can also write the vector V as the scalar A times the unit vector I plus the scalar B, which is the vertical component, times the unit vector J. Okay, and again, you're seeing out to the side that I is the unit vector with components 1, 0, and J is the unit vector with components 0, 1. Okay, so again, make sure you understand this. If you have a vector, a position vector that has initial point at the origin and terminal point at the point AB, you can write it like this, okay, in component form, or you can write it in IJ form. So this would be AI plus BJ. Okay, it says the scalar A is, of course, the horizontal component of your vector, and the vector B is the vertical, and the scalar B is the vertical component. So as an example of this, let me draw an illustration here. Okay, we looked at this particular vector earlier, I believe. In component form, it's going to be -4, -7. Okay, so remember what that means here. The initial point is at the origin, and its terminal point is at the point -4, -7. So let's go ahead and just draw this out. Okay, so here I'm going to go back to my standard scaling, every 1 unit or 1 unit every tick mark here. Okay, so I'll just put that on here. This is going to be 1 unit, this will be 1 unit, and so on. Okay, so the initial point will be at the origin. The terminal point will be at -4, -7. So we need to count that out. 1, 2, 3, 4. So here's -4, and then down 7. 1, 2, 3, 4, 5, 6, 7. Okay, so again, this is -4 on the x-axis, this is -7 on the y-axis. We would draw our vector in this direction. We would start at the origin and then draw to the terminal point of -4, -7. Okay, so pictorially, this is what the vector looks like. We've already seen that we can name it in component form. Okay, so like right here, the -4, -7, where you write the horizontal component, then you write the vertical component, and you put the brackets that look like angles around them. Okay, but the other way you can express this angle now, or sorry, this vector, you can write this as AI plus BJ. Okay, so A is the horizontal component, so you would put -4 times the unit vector I plus the B value, the vertical component, that's -7, times the vector J. Okay, so if you simplify that, this is going to be -4I minus 7J. Okay, so both of these are ways to write out this vector. Okay, as far as the IJ form goes, okay, it's basically telling you how to move in the I direction, which is along the x-axis, and how to move in the j direction, which is along the y-axis. If I start at the initial point, the origin, I need to do -4I, so that's -4 units along the x-axis. So I would go left 4, 1, 2, 3, 4. That brings me right here. And then I have to move -7 units in the j direction, which is paralleling the y-axis. So I need to go down 7 units, 1, 2, 3, 4, 5, 6, 7, and I end up right there at the terminal point. So again, this is just another way of being able to express a vector. Okay, if we go to the top of page 7, let's do some practice with example 6. It says write each vector in the form AI plus BJ. Okay, we have parts A and B, both are given to us in component form. We're just going to convert them over to AI plus BJ. Okay, so when you look at part A, we have the vector 6, -3. Okay, so again, if you were to draw this out, which we won't do, but I'll jot it down, the initial point here is the origin. The terminal point is going to be the point 6, -3. Okay, that's what it would look like if you were to draw it out. Okay, so to convert this over to AI plus BJ form, okay, we know that the 6 is your horizontal component, so that's the A value, and then the B value is -3 because that's the vertical component. So all we would write is 6I plus a -3 times J. Okay, so this would be 6I minus 3J. Okay, that's it. Okay, so let's try the other one. Okay, so for part B, we have the vector 0, -4. This is a position vector, so its initial point is at the origin, and then its terminal point would be at the point 0, -4. Okay, so we know that the first number here is the horizontal component, so that's good. A is going to be 0, and then the B value is going to be the vertical component, or the second number here, which is -4. So if we write this out, we're going to get, well, let me draw this here. We're going to get 0 times I plus a -4 times J. Okay, if we simplify this, 0 times, we're doing the scalar 0 here times a vector. Okay, so anything times 0, that's going to go away. So we're just going to be left with the j component here. Okay, so plus a negative, we can just make that a minus. So this vector is going to be negative 4j. Okay, it's all in the vertical direction. There is no horizontal component. Okay, if you were to graph it out, if I did a quick sketch, the terminal point here, like I said, would be 0, -4, so that's down here. Okay, so your vector would point straight down, okay, like this. Okay, there's only a vertical component, not a horizontal one.